go. Try not to bump over here.
I hope no one's allergic.
Here we go. I think we got everything taken care of now. All right, domain. Domain, what do we look for? And we have both. So x minus 4 has to be bigger than or equal to 0. And x minus 6 cannot equal 0. So both of these together go on the answer blank for question A. Got it?
Yes.
B. Take a look at question B. What do you think there? All reals. There is nothing, there's no denominator, there's no radicals, all reals. Text, you following along? Okay. Look at the next one, C. It has a radical, so whatever is under it has to be bigger than or equal to 0, so x is bigger than or equal to -5. And D, x cannot equal -7 because x plus 7 cannot be 0. Got it? Okay, so keep in mind, this is exactly what your test looks like. So everybody should get an A on that first part, right? We got this. Okay. Now, the second part, we are going to do now the asymptotes, poles for this function. Now, what is the first thing you probably need to do? Factor the bottom. And the reason that you are factoring the bottom is that sometimes stuff cancels. And when it cancels, you'll have a hole, right? Nothing cancels. So there will not be a hole in this problem. Does everybody see that the parentheses don't match exactly? So there's no canceling. Now, what about asymptotes? Well, where do vertical asymptotes come from? The bottom. So look at the bottom. My vertical asymptotes are where x equals 4 and where x equals -1. There are 2 of them. Because if you put 4 in for x, you're going to get a 0 in the bottom, right? Bad news. If you put -1 in, you're going to get a 0. All right, what about horizontal asymptotes? What's our strategy with horizontals? Box them in. Box them in. Now, when we box them in, we have to box the highest power, which is x squared. Well, there aren't any on the top, so I am going to put 0 of them up there. Right? That's how I do it. And then I'll end up having, that's a 1 there, so I end up having 0/1, which is 0. So my horizontal asymptote is y equals 0. So this kind of problem, sometimes we get 0/1, and sometimes we get 1/0. 0/1 is fine, that's 0. Hollis always says you can't sit on the egg. 1/0 does not exist. So there wouldn't be any asymptotes if you had that situation. Q?
So leave the fraction how it is, but take out the x squared.
Yes. Yes. They cancel. X squared over x squared cancels out. All right. You're welcome. What about this one? What do we have to do here? We're going to factor everything, right? We must factor everything because we have to see if something will cancel. How does the top factor?
X plus 3 or x plus 2?
3 and 2, that sounds great. 3 and 2. How does the bottom cancel?
X minus 5, x plus 3.
X minus 5, x plus 3.
We're going to have a hole of 3. didn't
See,
know that.
everybody good with the factoring?
Yeah.
Okay, we're gonna take our time when we factor and we're gonna double check by foiling, but we got it. So these cancel. So my problem really ends up just being this. This is what my problem ends up being. But the fact that I canceled out x plus 3 means I am going to have a hole, right?
Yes.
And where is that hole going to be?
It's gonna be
It's at 3.
The X one.
The X is gonna be -3?
Negative 3.
Oh, you
It's
switched
the opposite. Opposite. Always opposite, right? Now, how do I find the y?
Oh, over. In the
Plug
X.
in.
Plug in 30.
I plug it in right here. Right here. My new problem.
Why would you not plug in the V?
See how it says y equals?
Yeah.
This is how I get my y. I plug it right in. So negative 3 plus 2 over negative 3 minus 5.
So it's -1 over -8. So
Which
it's
is
1/8.
1/8. That's it. That's my hole. The y coordinate is 1/8. The hole is a point. Now the asymptotes are lines. Where's my vertical asymptote? Your beady little eyes should be looking right here. X equals 5. Horizontal asymptote, you're looking right here. That's 1 over 1, which is 1.
Can you go over the second part of the whole, like the 1/8? I just don't get
Put
that.
negative, what's negative 3? I put X is negative 3.
Yeah.
Put it right here. What's negative 3 plus 2? Negative 3, positive 2.
Oh, he's -1.
Negative 1. Negative 3 minus 5.
-2.
Negative, negative, negative. You owe $3 and you owe 5. Negative 8, you owe 8, right? Negatives cancel. 1/8.
So you just plug in the X.
That's right. Plug in the X. Okay. Hey, there's way too much talking. We have a test coming up. Why is your hand up?
Bathroom?
No, you were late getting here.
Please.
Where were you that you were late getting here?
I was just coming from another class. I forgot something over there.
All right, and then we're gonna talk after class.
What?
Hurry up.
So,
Now, as I'm copying it down, get going. If it's so bad you can't wait, get out of here, get going.
I'm sorry, don't come back here.
Now, I factored as I wrote it down, okay? Does anything cancel?
No.
No. Which means there will be no holes.
no help.
But there will be vertical asymptotes,
I got no.
right?
Yeah, you're gonna get -1 and 1.
One will be at -1 and one will be at +1. Because where do vertical asymptotes come from? The denominator. Okay? Now what about horizontal?
I got
Yeah,
one.
I didn't write, I should have written down the original problem.
I put 1.
If you look at the original problem, it's easy to see that your horizontal asymptote is where? 1 equals 1. Kids, don't be confused. It's 1 over 1. That's 1, right? That's easy. That's easy.
Take it.
All right, so that's the second part of the test. So let's recap really quickly here for the second part of the test. How do we get holes?
When something cancels.
Cancel. And let's say we had x plus 2 over x plus 2, so we canceled that out. Our hole would be at -2. The hole goes at the x factor that canceled out, right? Then, once I have the x, which comes directly from what canceled out, then I plug this into whatever I have left after I cancel, right? So if two of these had matched and I canceled those out, then my x would be at -4, and then I would plug -4 in here to get my y coordinate.
So you have the option to choose which one you want to do, -4, -1?
No. No, you plug in whatever cancels out. So if that canceled out,
flips.
then I would have to put -4 back in what was left.
Okay.
Where do the vertical asymptotes come from? The bottom. The bottom. Where do the horizontal asymptotes come from?
The top and bottom.
Yep, making the box of x squared over x squared or x over x, whatever it happens.
Where the highest power is?
Whatever the highest power is.
Oh yeah.
All right, so now we're going to do our piecewise function.
Oh yeah.
So we got x squared, x minus 1. All right, so here we go. So the first thing I like to do, you don't have to do this, but I'm going to go ahead and put my crease in my paper. That's where the break is, the fold is, however you want to talk about it. This is where my dots are going to be. Remember in these pictures, we have solid dots and open dots. The dots are going to be lined up right on this line. So the first equation is y equals x squared. Well, I know what that is. Y equals x squared is a parabola. Vertex at the origin, opening up, right?
I got this
Sam? Right? And it hits right here. And it's going to be a closed circle. And okay, so think of it like this. That parabola has been snapped right here. You have two pieces. You have this piece and this piece. One piece gets thrown away. The piece I keep is that piece.
Go with left.
So this gets thrown away. All right? Now, I'm going to graph the other thing, which is this. Now, what is that? That's the identity, but it's been moved down 1. So instead of going through the origin, it's going to go through down here, right? And look, it crosses right there, big dot. And this time it will be open. And I want to keep the left, so I'm going to erase the right. And there is the answer to the problem. All right, what else is in that section? All right, now we're sketching this one. What shape do we have? Parabola. Not vertex at the origin like this one, no. It's been moved
Up one.
right 1, up 2. So I'm just going to draw my little parabola right there like that. What?
How do you know which number does what?
Inside numbers go sideways, outside numbers go up and down.
How do you know when to switch them? Like when they're not?
Switch the inside one always.
Okay.
Yes, you do. All right, so next we've got this guy right here. what shape is he going to be? He's going to be a V. But instead of being from the origin, left one,
And up
up
one.
one. So left one, up one. And there's my V. I'm not sure what all this talking is about, but it's irritating me. We spend a lot of days reviewing, and we don't need to spend so many. We're not going to pay attention. All right, what shape is this?
Exponential.
This is an exponential, and this is one where you need to remember some of the specifics about the curve. The asymptote is right here on the axis, and this is the point 0, 1. That's what the exponential looks like, the regular exponential. Some of you are really lazy and you guys don't label your point and stuff. You need to know where it's at for this kind of problem. You need to know that 0, 1. Now what's happening to that picture?
It's going up there.
It's going up 2. So the asymptote that was right here is now going to be up here, right?
Yeah.
And the point that was at 0, 1 is now going to be at
3.
0, 3. So we have the exact same shape, the exact same picture, but it's been lifted up 2.
Does it have to touch the x-axis?
It doesn't touch the x-axis. The x-axis is down here. Yes, because normally it's at 0, so whatever you put on the end is how many you're picking it up. All right, now the next one. This is our cosine, and we talked a little bit about this yesterday, that the cosine and sine are probably the trickiest. What's happening to this cosine? Moving 2 down. So I'm going to go ahead and sketch my regular cosine. And remember, that's the one that starts like up here. It straddles the x-axis or the y-axis, right? So there's my cosine. Not very symmetric. There's my cosine. Now that is not the answer. That is the regular cosine. That's what I memorized. Now, I'm going to take everything in that picture and drop it down 2. Right?
Yeah.
So what does that mean? If I drop everything down 2, then that means the high point, which was at 1, is now going to be down here.
Yes.
That's going to be the high point. And the low point, which was at -1, is now going to be clear down here at -3. So I'm going to have this is my cosine. Drop down 2. When I grade that picture, what am I going to be looking for? I'm going to be looking for, that's the high point right there. It used to be at 1, now it's at -1 because it got dropped down 2. I'm going to be looking for the low points to be at -3. If all you have is some squiggly line down there, you're not going to get full credit. You have to show me that you know what's going on. And one more graph. All right, what shape do we have here? Oh my gosh, Mrs. Ford just got wild and wacky on you. Totally wild and wacky.
It's like that one.
It's a square.
What in the heck?
Whoa,
Whoa. All right, so let's cover that up for a minute. Let's pretend that's not there. Okay? Pretend it's not there.
Crazy. Oh.
We know what shape this is, right?
Yeah.
What's happened to it?
Move
It's
to
moved
the right 2.
Two to the right.
To the right.
So it is sitting here, right?
Yeah.
And then you switch it.
What do you mean switch it?
You're gonna invert it.
Do the opposite.
Upside down. Upside down. When you put a little negative out here, it turns it upside down. Now, before you start yelling and screaming at me, I want you to remember last year when you graphed your parabolas, right? Here it is. But once in a while you had one that looked like this. What did that parabola look like? Upside down. Because what does a negative out in front do?
Changes
It
it.
takes your picture and basically turns it
So
upside
that
down.
only happens when there's a negative in
Oh, when a
front.
negative out in front, yep. So the answer is actually the red piece. The red piece is actually the answer because of the negative out there in front. Now, those of you that did your homework know there was at least one like that in the homework snuck in there. So here I am being sneaky, sticking it in. So, now we've finished another section of the test, the graphing section. So on Friday, you'll have to do a piecewise function, and then you'll have to sketch a few, 4 or 5, of your BFFs moved around. Okay? Now, the next section is the function section. Do not let the letters worry you. On this test, it's P and Q. On one of them, it was M and N. On one of them, it was F and G. It doesn't make any difference. Your test might be A and B. Who knows? It doesn't matter. So question number 1 says this. What am I doing with that?
You're multiplying the two functions together.
I'm simply multiplying them together. Kids, it couldn't be any easier. P of x is 2x squared. Q of x is negative 3x plus 1. The problem says multiply those. So negative 6x cubed plus 2x squared. That's it. Same two functions. What does this mean? This means put P into Q. Okay, so what's P? 2x squared. Now I'm going to take that and put it right here. I'm putting the P function in for the x in the Q function. So that will be negative 3 2x squared plus 1. Negative 6x squared plus 3, plus 1. Ashley, you awake, honey?
Yeah.
All right, let's stay focused. I know it's the last period of the day, but man, it's a big, important day for us. We have a test. All right, C.
So,
What does this mean?
you plug in -1 for the Q function, then add it to the
2
function.
goes into the P function. One more time. I cautioned you about this yesterday. Watch your order of operations. When you put 2 in there, you must square first. So 2 squared is 4 times 2 is 8. Now that seems so simple, but somebody's going to mess that up. PEMDAS, PEMDAS, PEMDAS. All right, now -1 goes into Q. So negative 3 times -1 plus 1. What will that be?
4.
4. And the problem tells me to add them, right? So that's going to be 12.
Whoa.
And the last one says find P of Q of 0.
2.
So, step one,
Zero for Q.
0 in for Q. So 0 in for Q would be
1.
just 1, right? And then I'll take the 1 and put it into
1 squared times.
P, and that means 2 times 1 squared. 1 squared is 1 times 2 is 2. And that's the answer to the question. We're almost done, guys. Now we need to find, chill out, the test has 5 parts, and you'll see there's a 6 on there. Wonder what that is.
Bonus.
Oh, maybe. Oh, maybe. All right, so x squared minus y squared equals 25. This is not bonus, this is mandatory. This is how do we find implicit functions? What do we do?
Y by itself.
Okay, y by itself.
Y by itself. So you can do that however you want. If you subtract x squared, this is what you're gonna have. And then you gotta divide by -1, which changes all the signs and leaves you with that. Some of you may write that like this, and that's the same thing. These are exactly the same. It doesn't make any difference how you write it. And then there's one more step. What's the very last step? Square root. And notice, this practice test is formatted just like your test. See the answer blanks over here, folks? Y equals, Y equals. So your 2 answers are the square root of this, and what's the other one? Negative square root. Now, please note that we do not simplify, and that whatever is in the radical on both problems must be exactly the same thing. One has a negative out front, one doesn't. But if you go messing around with what's in here and they don't match, then you're going to miss what's probably the easiest problem on the test. Right? That's the answer. Okay, now let's look at this last thing. This is kind of crazy.
You're going the opposite way.
You're going the opposite way. That's exactly right. So you have been told that there are 2 functions out there called m and n. And when you put one inside the other, that's how we do composition, right? When you put the n into the m, that's what you end up with. So what were the 2 functions where that would happen? Well, first of all, functions have to have an x in them, all right? So, but you kind of got the right idea. I want you to think about, listen, this is not hard, but we're not going to waste a bunch of time on it. This is the one we're doing, okay? So listen, if I said to you, put a 5 into this thing right here, put a 5 in, what would be the first thing you do to that 5? Times it by 3. All right, now wait. So in this notation, isn't this the first function? So that means your n function has to be the one that times us by 3. So it's 3x. It times us by 3.
Oh, I see.
So once we put the 5 in, what would be, and we did that, multiply, what would be the next thing we do? Subtract 7. So now our m function, our second step, has to be the function that subtracts 7. So your functions, you do something to x. So when you said I need to multiply by 3, that function is 3x. Then when you say I need to subtract 7, that function is x minus 7. It's x, x, x. Every one of these, however many there are are gonna be doing something to x.
Well, you would, yeah.
So x times 3, x minus 7. Those are the answers. Okay? I won't waste any more time on that, because that is not in it. That's the whole test. So now I'm gonna hand, I got some other stuff, I got some other stuff to talk about. I wanna get right into it back. Okay. You guys have any
Bro.
I know that, Sam, but I have
It's a like you know the college is like that's why I'm like that's what I just said.
Yeah, I struggle with that too.
Like before I started college, I was like college
But then I'm like, whatever number's affecting the x moves it left to right. And the number outside of whatever is affecting x moves it up and down.
Wait, you can ask that. The inside is left to right. Okay, I always mess that up.
I did for a while. And you switch that sign.
Hold it out of
These were worth 11.
It's like
Almost.
So please double check this. These were worth 11.
I don't
I'm gonna say that 23
like, ow, I'm sorry.
results Brendan.
Oh, I knew it.
Please tell me you got better. I'm sorry, I forget.
That's cool. I'll start with you. That's cool. I'll start with you. Probably still anchor though.
It's sorry, you, Charlie, Nate.
Santo's riding the bench all
Hey,
you.
Carter, hey.
Mr. Crableg over there is riding the bench.
Now, quiet. I want to hand out, this is an old quiz that I gave, but it has some really good review on it. So, as you get your paper, would you start filling in the domain questions?
Oh.
So quickly, start filling in the domain questions at the top. We're going to treat this like a review. Did everybody get one?
We're doing more of these problems. Always still got 15 minutes, you know, big one. Ever. You're all about that business in this class.
I'm going to go ahead and give you another one.
They want you.
Mr. Stewart is almost done with the whole front page.
Hey, I am too.
Okay. So I've given you 2 papers. We're going to quickly go through.
Another?
Yes, we got to cram in as much review as we can. All right, so what did you say the domain is for the first problem? All real. Now we're going to go down. we're gonna go down through the answers. You mark the ones wrong that you missed, and then at the end, we'll come back and look at those, okay? But we're gonna get through all these problems. So A was all real numbers. B, X cannot be 2. C, X is bigger than or equal to 2. Next set. Now notice in this set, there's no mention of holes. Can somebody tell me why there is no mention of holes in this next set of problems? Nothing cancels. If you look at all those problems, there is nothing canceling. So if I had put holes on there, they would all be none. Okay? So I didn't do that. All right, so for A, your vertical is X equals 2. Your horizontal is Y equals 3. If you know what you are doing, there really isn't any work on that problem, right? You should be able to look at it and see X is 2, Y is 3. Next one. The vertical asymptote is X equals -1. And the horizontal asymptote is none, none, none. Because in this problem, you have no X squared, you have 1X squared over no X squared. Right? Are you allowed to have 1 over 0? No. That's why there's none. Vertical is X equals -2. Because if you set this equal to 0, you come up with -2, right? Yep. So that's what X can't be. That would make the denominator 0. -2 would make it 0. Your horizontal asymptote is Y equals
So it is
5 fourths.
equals 2, or it's, so that's X equals -2.
That's your vertical asymptote. For D, your vertical is X equals 0 and your Y, or your horizontal is Y equals 0. Because on that one, it's 0x squared over 5x squared, right? And what's 0 over 5? 0. So your horizontal asymptote is Y equals 0.
What was your arithmetic for D at the D and then the vertical asymptote?
What makes the denominator 0?
Okay.
Your vertical asymptotes are cannot be's. What makes the denominator 0?
So how did you? I was confused because I calculated the arithmetic wrong.
Okay, set x squared equal to 0. Take the square root of those sides. To find the vertical asymptote, you set your denominator equal to 0 because there cannot be. Your denominator can't equal 0.
Right.
So x squared equals 0.
Oh wait, no, you're right.
Both sides, x equals
I did it right. I was just taking it wrong.
All right, number 3, name. Let's name them. What's A? Logistic. What's B? Sign. What's C? Cubing or cubic, doesn't matter to me. And what's D? Exponential. Now, you're thinking to yourself, well wait, Mrs. Ford, I already took my BFF quiz. But you need to know that because you're going to have to do these graphs like on the bottom of the page, right? You're going to need to be able to graph this. What shape? Well, it's absolute value, so it's a V situated 1 unit to the left.
Cake.
What about B?
-2 stars. Go down 2.
Go
Down.
down 2 and
Make it you,
put
touchdown.
your parabola down at 0, -2, right?
Square root.
What about C?
Go down 2. Yeah, down 2,
So
left 2.
left 2, down 2.
Square root move.
-2, -2. And it has the square root shape.
Yep. I'm acing this board.
And what about D?
Identity to the right 3.
No, well,
Oh wait, up 3.
up 3, yeah. It's
Yeah.
identity up 3. Now, Kyle, I don't want to confuse anybody, but as it turns out with the identity, it doesn't matter, because if I shifted it to the left or up, it's gonna get in the very same line. But we've been talking about him as moving it up.
Okay.
All right, let's get off the other one.
Yeah, it is.
She wants to hammer this thing.
The other one has, this is two different quizzes that are just two versions of the same quiz. So let's look at the side that's labeled 2. So it's the quiz, one side's labeled 2, one's labeled 3. Let's look at the side that's labeled 2. Where are the asymptotes for this? So 1 is at x equals -1, that would be your vertical.
And one is.
On the test, you're not going to be graphing it. You're just going to be writing down x equals -1. That's your vertical asymptote. Where is your horizontal asymptote?
Up 2. Oh, wait. Oh, 1.
Y equals 1. Because how do we find horizontal asymptotes? We do this right here, right? We compare x's. If you keep messing that up, you need to do somehow you gotta remember it. So you need to say it over and over, you need to practice it over and over, I don't know. But it's easy, you just gotta remember what to do. Now number 2, we had a quiz over this, but this is not on the test. So I tell you what, let's hold off on it.
Yeah, let's not do it.
And let's do the bottom one, because the bottom one is on the test, right? Domain. What is the domain of this function?
X is greater than or equal to 2.
X is greater than or equal to 2.
X cannot equal 7.
X cannot equal 7. You gotta write it separate. Let's not be lazy. Let's do it the way we've done it since the beginning. And that is we have 2 separate answers. Okay? Does everybody understand where those 2 separate answers came from?
Yep.
This one came from what's under the radical greater than or equal to 0. This one came from what's in the denominator cannot equal 0. Right? All right, turn it over. Let's do 2 and 3 on your own, real quick. Do 2 and 3 on your own, on the back side. So quiz 3, number 2 and number 3, do it real quick. Show whatever work you need to show, kids. Do not skimp.
No, not these ones. These are the ones that's.
2 and negative.
No, it's question 2. Well, I know how.
Okay, Maddie and Pat are out. Is there anybody else? We need a harder problem. I love it.
You tweaking, cousin.
I get good news or bad news. They aren't any harder than this. This is exactly what's on your test. So, domain. What did you say?
X is greater than or equal to -1, and X can't equal 2.
If you said that, you are flawless. That is exactly what you should have. Now, what did you say for vertical asymptote?
Vertical. Negative 2.
Well, if you said -3, you're going to get half credit. To get full credit, you got to say x equals -3. X equals -3.
I got an A on that.
What's your horizontal asymptote?
Y equals 2.
Y equals 2. Right here. Y
Yep.
equals 2. Kids, vertical asymptotes are cannot be's. What number would make the denominator 0? -3. That is the only number. Solve it. Solve it out. You don't have to do it in your head. Solve it out. X can't be -3. Cannot be's are vertical
Can't be
asymptotes.
-2, 4, 6, and 8.
Okay, so here is, your phone just fell out of your pocket. Here is the plan.